Welcome to the new session. Hope you all remember what we have seen in the last session. We have discussed the harmonic functions. You know now how to check whether a given function is harmonic or not. And also, if I give you a function which is harmonic, you know how to find its harmonic conjugate. Which method did you use to find the harmonic conjugate there? We have used the property of analytic function, that is the CR equations, and then we have obtained the conjugate part of it, that means the harmonic conjugate of the given function. So, there is still an easier method to find an analytic function if either the real or imaginary part is given. So, the name of that method is Milne-Thompson method. So, let us see how do you use that method to find a function f of z is equal to u plus iv, which is analytic. So, if you know either u or v. Let us start with the first case. You want to find an analytic function f of z and your real part u of xy is given to you. So, how do I use this method? Since u is with you, you can find the first and second order derivative of u. That means you can find ux and uy. And you have to find an analytic function f of z such that u is its real part. And since you know that if f of z is analytic, your f dash z can be written by using the formula ux plus ivx. We have seen this formula in the previous session when we have derived the CR equations. So, you know that f dash z is ux plus ivx, and since your fz is analytic, it satisfies the CR equations. So, your vx can be replaced by minus of uy. So, you get a new equation for f dash z, that is the derivative of derivative of fz, which is ux minus iuy. Now, I have the derivative of a function f dash z, and now I have to find f of z. So, what do? I can just integrate with this function with respect to z. But for that you have to ensure that your ux minus iuy, which is your f dash z, is containing only the variable z. It should not be in x and y. So, in order to make ux minus iuy as a function of z, what we do is you substitute x is equal to z and y equal to 0. How do you get that x is equal to z and y equal to 0? You are putting actually z equal to z bar. So, what happens? Your x becomes z and y is equal to 0, because you know that x is z plus z bar by 2 and y is z minus z bar by 2y. So, when I substitute z is equal to z bar, my x becomes z and y becomes 0. You can do this only because your fz is analytic. Now, you get f dash z as a function of z, and now how do you get fz back? You just integrate that function with respect to z. So, if I give you a function u, which is supposed to be the real part of the analytic function f of z, you write your f dash as ux minus iuy, put x equal to z and y equal to 0, and then integrate with respect to z. Now, in the same way, I have to find f of z, but in this case, instead of u, v, that is the imaginary part of f is given. So, how do I proceed? Here also the method remains the same, but since v is in your hand, you find its first order derivative vx and vy, and now instead of using ux minus iuy in the earlier case what you have done, here I use the corresponding formula with the partial derivatives of v. Since f dash z is ux plus ivx, you can replace your ux by vy because your fz is analytic. So, my f dash z reduced to vy plus ivx. So, now again to make it a function of z, what you do? You do now put x is equal to z and y equal to 0. Now f dash z is a function of z, and how do you get your f z back? Again, in the same way you proceed, you integrate f dash z with respect to z. So, once you get your f z, which is analytic, now if I ask you to find the imaginary part or the real part accordingly, that is in the conjugate, you can just separate the real and imaginary part of f of z and then find it. So, this method becomes easy when you simply want to find f of z as a function of z if either u or v is given. So, let us see how to find an analytic function if the real part is given. Say for example, we will consider a function u. So, u is given to you, that is u is e raised to x cos y. So, I have to find the analytic function whose real part is e raised to x cos y. So, using the method of Milne Thompson will be easier here because you have to find an analytic function f of z in terms of z. So, how do I proceed? Since u is given to you, I use the equation of f dash z as ux minus iuy, and as we have seen, it is actually obtained from which equation? It is obtained from the equation f dash z is equal to ux plus ivx. You are replacing this ux, sorry, not this ux, this vx by minus uy, because you are going to find an analytic function f of z whose real part is u. So, since the function is analytic, the CR equations are satisfied and vx can be replaced by minus uy. So, I have ux minus iuy as my f dash z since u is given to me. So, if I find ux and uy and substitute in this equation, what do I have? I have e raised to x cos y minus I into, what is the derivative of this with respect to y? So, it is nothing but e raised to x into minus sin y. So, I write it as plus I e raised to x sin y. Now, I have to find f z. So, what do? I put x is equal to z and y equal to 0, so that I get an expression for f dash z in terms of z. Then in order to get f of z back, I can just integrate that with respect to z. So, I substitute x equal to z and y equal to 0. My f dash z reduces to e raised to z into 1 plus I into e raised to z into 0, which is nothing but e raised to z. So, what is your f z? Your f z is the integral of this with respect to z, that is nothing but e raised to z plus c. So, this is how you proceed and find the function f of z analytic in terms of z if your real part is given. So, what do you do if the imaginary part is given? Let us see that with another example. So, if I start with a function v given to you and ask you to find f of z, the only difference here is you use the equation vy plus ivx. In the same way you proceed and substitute x equal to z and y equal to 0, and then you can say you can find f of z by integrating that function with respect to z. Now, suppose I give you a function u and ask you to find v, that is the harmonic conjugate such that u plus iv is analytic. Still you can use the Milne Thompson method. First, what do you have to do? You have to find your f z and then separate it into real and imaginary part. In this case, you can also verify whether your function is correct, because you are actually separating it into the real and imaginary part. So, you can verify whether the real part is the given function to you. So, now suppose your u is given as e raised to 2x into x cos 2y minus y sine 2y. So, if I proceed e raised to 2x into x cos 2y minus y sine 2y. If I proceed in the same way as the previous problem, I write my f dash z as ux minus iuy. So, I have to find my ux and uy for that. So, what is your ux? Ux is e raised to 2x into x cos 2y minus y sine 2y, so into 2, plus you have to apply the product rule, plus only for this term will you have to use, so e raised to 2x into, if I find the derivative, there is only one term here containing x, so it is e raised to 2x into cos 2y. Now, I have to find uy. So, again it is e raised to 2x is a constant here. So, x into the derivative of cos 2y is minus 2 sin 2y. So, here I will have to apply the product rule. So, it is minus sin 2y minus 2y into cos 2y. So, if I put x is equal to z and y equal to 0, so I get my function reduced to a function in z. So, what is your f dash z now? So, I put x equal to z and y equal to 0. So, you get 2 e raised to 2z. So, here cos becomes 1 and sin becomes 0. So, it is into z plus e raised to 2z. This is your real part minus I into e raised to 2z into this term, these three terms become 0 because you are putting y equal to 0. So, your I part becomes 0. So, now my function f dash z, reduces to e raised to 2z into 2z plus 1. Now, how do I find my function back? I have to differentiate this, integrate this with respect to z. Once you get a function in terms of the variable z, you can directly integrate it. So, this is equal to 2z plus 1 into e raised to 2z by 2 minus 2 times e raised to 2z by 4 plus c, the constant of integration. So, what do I have? Now, let me simplify this expression. So, it becomes z e raised to 2z plus this becomes e raised to 2z by 2 and this is also nothing but minus e raised to 2z by 2. So, that cancels and your function f of z is z e raised to 2z plus c. Now, you got your analytic function f of z in hand, whose real part is given to you as e raised to 2x into x2 cos 2y minus y sin 2y. What is the problem? Your problem is to find v. How do I proceed now? Once I have the analytic function, how do you find the imaginary part? You just substitute the real and imaginary, what z is equal to x plus iy and separate the real and imaginary part as you have done in the earlier problems. So, I replace my z as x plus iy and now you will have to collect the real and imaginary parts. So, here c is your constant of integration. So, again x plus iy, what do I have here? E raised to 2x into e raised to I 2y, that is nothing but cos 2y plus I sin 2y. So, now if I collect, I want my v because u is given to you and now we have to find v. So, v means the imaginary terms in this expression. So, e raised to 2x will remain and let us collect all the terms which will have an I. So, x into sin 2y will be one term and the other term will be plus y into cos 2y. So, there is no more information about the constant of integration. It can either be a real constant or else a complex constant. So, let us add that c together with v. So, your v is nothing but e raised to 2x into y cos 2y plus x sin 2y. So, that means you can also use Milne-Thompson method to find the harmonic conjugate if either u or v is given to you. You proceed, first find out your analytic function using the method and then separate it into real and imaginary parts. The first method what you have learned is only to use the property of analyticity, that is the CR equation, to find out the harmonic conjugate. We can also use this Milne-Thompson method to find your analytic function if suppose instead of u or v, I give you u plus v or u minus v. Still you can use this method to find the analytic function. How do you proceed? So, to find Fz is equal to u plus iv, which is analytic, if either u plus v or u minus v is known to you or else it is given to you. So, you know that Fz is equal to u plus iv. So, what will happen if I multiply it with I? So, Ifz will be iu minus v. So, 1 plus I into f of z, you collect the real and imaginary. So, it is u minus v plus I into u plus v. So, what do I have now? Instead of Fz, I have a constant multiple of Fz whose real part is u minus v and the imaginary part is u plus v. So, you can still use the Milne-Thompson method here, but in that case, so let us call this u minus v as capital U and u plus v as capital V. So, now instead of f of z, I have 1 plus I f of z whose real part is u minus v and the imaginary part is u plus v. Now, if I give you u minus v and ask you to find your Fz, what do you have to do? You can find 1 plus I f of z whose real part is u minus v. That means, you can proceed in the same way we have done using Milne-Thompson method, but in this case the real part of 1 plus I f z is given to you instead of f of z. So, here there are two cases that can happen. Your first case is u minus v is given, that is your capital U. So, how do I proceed? Using Milne-Thompson method, I have my 1 plus I f dash z as capital Ux minus I capital Uy. So, once you get this expression, I want a function in z, for that you substitute x equal to z, y equal to 0. So, I get my 1 plus I f dash z. In order to get f of z, you integrate it in the normal way with respect to z, and after that you need to divide the function by 1 plus I. Now, in the second case, if u plus v is given, that is the capital V which you have denoted as u plus v, in that case I have my 1 plus I f dash z as Vy plus I Vx. So, now this is the second case in your Milne-Thompson method. So, 1 plus I f dash z instead of f dash z is Vy plus I Vx. This capital V is nothing but u plus V. So again I substitute x equal to z and y equal to 0, make it a function of z and then integrate it to get 1 plus I f of z. Whereas in the earlier case we have obtained f of z by integrating. So here in order to get your fz back, what do you have to do? You have to divide the function which you have obtained by 1 plus I. See, this method can also be used if instead of u plus v and u minus v, any linear combination of u and v are given. So, whenever instead of u and v known to you, either u plus v, u minus v or else any linear combination of u and v is known to you, still you can find your fz back, whose real part is u and the imaginary part is v. So, let us see one example to find an analytic function f of z is equal to u plus I v if say some linear combination of u and v is given to you. So, let us do one example. So, here you have to find an analytic function f of z is equal to u plus I v, but I am going to give you not u plus v or u minus v. The method remains very simple. You can use Milne Thompson, for which we have done 2 problems earlier. But here in this case, I am going to give you 3u plus 2v as a function of x and y square minus x square plus 16x. Okay. So, if I have a function which is a linear combination of u and v, still you can find the analytic function. I have already told you, you can either use Milne Thompson method, but this is a direct analytic method what we are going to use. So, I will differentiate this equation with respect to x. So, what do I get? 3ux plus 2 times vx is equal to minus 2x plus 16y. Now, I can differentiate this with respect to y. I get 3uy plus 2vy is equal to 2y plus 16x. See, you know that now I can use this equation, make it into either ux and vx and then obtain f dash z. For that, since you are trying to find out f of z, which is an analytic function, you can always use your CR equations, and the CR equations are nothing but, I hope you have not forgotten the equations, ux is equal to vy and uy is equal to minus vx. So, I have this equation, I will call it as 1. I am going to make these 2 variables also as ux and vx. So, this equation, so 2 becomes uy has to be replaced by vx and your vy has to be replaced by ux. So, I write it in the same order as equation 1. I get 2ux minus 3vx is equal to 2y plus 16x. So, now I have 2 equations in hand and I can solve them simultaneously to find your ux and vy, ux and vx. So, what do you get your ux and vx as? You get your ux as, so solve it simultaneously, you get your ux as 2x plus 4y. Now, I can also get my vx by simultaneously solving which are the 2 equations which you are considering. You are considering the first equation and the third equation and you are solving it simultaneously. I get my vx as minus 4x plus 2y. So, I now got my ux and vx. So, now you know your f dash z is ux plus I vx. So, you have to just write it together. So, what do I get my f dash z as here? So, it is your ux is 2x plus 4y and your vx is minus 4x plus 2y. If I have to obtain this in as a function of z alone, so that I can integrate and get my fz back, I will put x is equal to z and y equal to 0 as in the Milne-Thompson method. So, my equation becomes, so if I put x equal to z and y equal to 0 here, I get 2z here and I get minus I into 4z as my f dash z. So, in order to get my f of z, I integrate it, which is nothing but z square z square minus 2i into z square plus c, which is nothing but 1 minus 2i into z square plus c. So, without using Milne-Thompson's method also, you can proceed and find out your f of z if I give you any linear combination of u and v. So, here in this session, what all things have we learned? We have actually learned a new method to find an analytic function f of z is equal to u plus iv when you either know u alone or else v alone. That means, if I give you the real part of an analytic function or the imaginary part of an analytic function, you can find f of z using Milne-Thompson's method. And as an alternate to finding the harmonic conjugate, you can still use this method. You have to still go further and find out f of z by separating it into real and imaginary part. So, if u is given to you, you can correspondingly find v and vice versa. This method still works if u plus v or u minus v is given to you apart from u or v. The method is slightly modified. In this case, we will get 1 plus I f of z instead of f of z, but still you can go ahead and find f of z by dividing it by 1 plus I. Also, this can be used when any linear combination of u and v is given, but this method which I have explained just now is also an easy method to find your f of z which is analytic if I give you any linear combination of u and v. So, here we have considered an example where 3u plus 2v is given, still you find f of z very easily. So, please keep in mind, if I have my f of z and I have to make it a function of z, put x equal to z and y equal to 0, which is nothing but you are putting z equal to z bar. Thank you for listening to me. I hope you all enjoyed this session. Try out more problems so that this will be more clear to you. We will continue with another session. Thank you.